Hi everybody. Do you hear my voice? Do you hear my voice? Do you hear my voice? Okay, we start the class. Do you see the presentation?
Not very clear, Doctor.
Presentation. Okay. Okay, thank you. We start the second session of advanced thermodynamics. According to yesterday's session, I told you that we have a review on basics of thermodynamics. And if you have any question about the basics of thermodynamics, you can ask me freely. I repeat some section of yesterday's discussion and continue the lesson. We talk about control mass and control volume that are familiar with it from basic thermodynamics. Control mass has no inlet at outlet of mass. No entering, no output of mass. But control volume has inlet and outlet. Maybe both of them or one of them. We talk about some definition. A specific volume, phase, state, and two category of thermodynamics: intensive and extensive. Intensive doesn't depend on mass, and extensive directly depend on mass. We talk about thermodynamic equilibrium, process, cycle, zero law of thermodynamics, pure substance. Pure substance is substance that is homogeneous and invariable chemical composition. So composition is the same, but it can exist in more than one phases. For example, liquid and water that you see in the picture. We talk about saturation temperature, saturation pressure. Diagram of T versus volume of change phases of water in different pressure, 3D volume, 3D presentation of P, volume, pressure, volume, and temperature. We also talk about table of thermodynamics, that you are familiar with it from BA thermodynamics. We did example. Please do this example yourself in the home and check the answer with the result of the answer in the picture. We talk about quality. Quality means substance like water exists in more than one phases. Salt. Okay. My voice is better now. Is my voice better? Do you hear my voice? Okay, but if you want to write me sentences or some words, please write in English. Okay, you can use Google Translate. If you can't speak English, please write English words of what you want. Okay, we did another example. We talk about superheated state, an example of that. Okay, we continue the lesson. You are familiar with compressibility factor. All you know about the ideal gas relation. Pressure cross specific volume equal to gas constant cross temperature is ideal gas. But what is a real behavior of gases in high pressure or high temperature? All of it in ideal gas behavior? No. We know from it compressibility factor. Okay, compressibility factor. Compressibility factor denoted by or present by the letter Z. Z equal pressure cross control volume divided by gas constant cross T, temperature. Like PV equal to ZRT. For
So,
ideal
doctor,
gas, the Z equal to 1.
so, doctor, Z
But in
equal,
high temperature or high pressure, Z is not equal to 1. You see it from this picture. This compressibility factor of nitrogen. Nitrogen, why nitrogen? Because more than 80, about 80% of air is nitrogen. So if we investigate compressibility factor of nitrogen, it's like the compressibility factor of air. So if you investigate or study this picture, compressibility factor equal to 1 means that ideal gas. So in what condition we can use the ideal gas? You see it from this picture that at low pressure or temperature near 3000 kelvins is equal to 1. But in high pressure or low temperature, we should determine the compressibility factor. We need two parameters, radius pressure and radius temperature. Radius pressure P index R equal to pressure divided by critical pressure, and radius temperature equal to temperature divided by critical temperature. We have two parameters, T index R and P index R. With two parameters, we can determine the compressibility factor Z from this picture. You can also this graph in the end of the thermodynamics book. I also uploaded the advanced thermodynamics book, that is Van Wylen book, from the in the LMS site. You can download it from the site. So we have two parameters, P index R and T index R. So T index R where are in the about 5 or near 2 is equal to 1, and PR, you can see PR from the horizontal axis, radius pressure, and TR from the curve. You can see this curve, right? 5 to 1.5, 1.3 is a value of TR, and the value of PR is on horizontal axis. Okay, this is compressibility factor. In ideal gas, we investigated in other lesson in the future session that for ideal gas behavior we use the relation between pressure, specific volume, and temperature. So we will use it in the next lesson. This is ideal gas behavior. Okay, any question? We talk about the other important law of thermodynamics. Do you hear my voice? Please add some in the, yes, okay, thank you. We talk about the other important law of thermodynamics. First law of thermodynamics. Many problem of in mechanical engineering and other physical phenomena or project use the depend on first law of thermodynamics. Everywhere that we have a temperature, we talk about temperature, we talk about heat, we talk about work, all of them is in the first law of thermodynamics. It's the most important law of the thermodynamics. First law of thermodynamics is the rule of energy. Energy not destroyed or created, and it can convert from one state to other state. You can see it in the mathematical format that D index E CV means control volume. E point dot is up means that differentiate of quantity with respect to time. So E dot equal to Q dot. Q is heat. Heat may be input, enter to the system, or out of the system. Minus rate of work. Okay, D divided by T means rate to time. So rate of energy equal to rate of heat minus rate of work. This is first law of thermodynamics. But what's the means of energy of control volume? Energy of control volume is combination of internal energy that denoted by U, kinetic energy, and potential energy. You can see it in the below figure. Between two states, the integral of this expression means E index 2 minus E index 1 equal to
Sorry, doctor.
U index 2 minus U index 1 means variation of internal energy plus variation of kinetic energy. 1 divided by 2 cross m, that is mass of the material, cross velocity of the matter power 2 plus m, that is mass of the matter, cross z index 2 minus z index 1. Z means height of the matter from one reference point. This is the first law of thermodynamics. It has another explanation, that integral of heat equal integral of work in a cycle. Okay, in a cycle, integral of del Q equal to integral of del work. So what is work? Work is capability of displacement of the matter. Okay, consider to the picture. We have a battery electrical motor. That battery connect to electrical motor. It can revolute the fan. So if you displace fan with a pulley and weight, it can increase the height of the weight. Okay, so work means capability of energy that can height the matter. So what is the work in the control mass? Consider simple cylinder and piston. We put a material with mass m on the piston. So what happened when increases the mass very low? Consider 1 kilogram mass put on the piston, and we put also 1 gram other material on the piston. So due to increase the mass of the piston, the pressure inside the cylinder increases. So piston is moved to lower location. So what is the work? Work means force cross displacement. You all know it from statics dynamics lesson. What is the work? Force cross displacement. But in thermodynamics, we have not an actual meaning of force or displacement. Displacement is not important. other parameter is important in thermodynamics. What is important? Pressure, temperature, volume. So we should convert the force and displacement to quantity of pressure, temperature, and volume. So what is the force in this cylinder and piston? Force means pressure of cylinder, pressure inside the cylinder, cross surface of piston, P cross R. And what is displacement? Consider we have a displacement very low, dl. So P cross R cross differential of L. So A cross dl equal to variation of volume. So this is equal to pressure cross differential of volume, P differential V. So P has meaning in thermodynamics, V has meaning in thermodynamics. So we accept this definition in thermodynamics, P cross del dot V. So if we want to compute work in the cycle, we can integral this term, but it depends on the curve of P versus V. You can see an example of work in this example. Consider a piston and cylinder at arrangement to this figure. In this example, piston is loaded with a mass M index P and atmospheric pressure P index 0 and a linear spring. So the piston trapped the gas inside with pressure P. A force balance on the piston. What is the force balance? Balance means steady, means no acceleration. So we have a first law of thermodynamics. When acceleration is 0, plus of every forces on the system is equal to 0. So what forces are exist in this example? First, mass of the piston, M cross G. Pressure inside the cylinder cross the surface of piston, Pcf cross R. And a spring is It seems that we have a problem. I can exit from the LMS. Okay. You can see the lecture. Yes. Okay. What's the final topic that you hear my voice? We talked about the first law, okay, and work. And to how to compute the work in thermodynamic process. Okay. We did example and we try to other example. Okay. Any question? Okay. This is example. What is this example? Is example of cylinder and piston. Consider a system that gas inside the cylinder. Piston and cylinder is no friction between them. Initial pressure of the system is 200 pascals and the initial volume of the gas is 0.04 cubic meter. We want to compute the work in several processes. In part A, we consider a constant pressure process. What is the constant pressure? It means that pressure is constant during this pressure. So if we want to compute this integral due to constant of pressure, we can put it outside the integral. So work is equal to pressure cross V index 2 minus V index 1. In the other B part, we can use the constant temperature process. Constant temperature process, like the Stirling engine that you are familiar with it, is assumed that ideal gas relation. Due to ideal gas behavior, P cross volume equal to mass cross R cross T. So we can compute pressure from M cross R cross T divided by volume. So we put instead of P in this integral M cross R cross T divided by V. And if we compute this integral, is equal to P1 cross V1 cross natural log of V index 2 divided by V index 1. So this other process. The other process is that polytropic process. Polytropic process with index n equal to 1.3, n equal to 1.3. So P cross volume power of 1.3 equal to constant. So we put this term in this integral and we compute the integral and compute the work of the system. Okay, any question of this example? Student Nazar Ali, all the students are free to enter the class. all the students are free. It's not it doesn't need any acceptance to enter to class. All of them can enter to class freely. Yes, it's accepted. It is accepted for all of you. Okay, any question? Okay. Yes, in the second part B, you can use the ideal gas behavior. So we continue the lesson. When we want to compute the work from this expression, it means that quasi-equilibrium. What is the quasi-equilibrium? It means that pressure is varies very low in the process. So increasing or decreasing of pressure is very low during this process. Consider that you want to from pressure varies pressure from 1 bar to 2 bar. What is happened in the quasi-equilibrium process? It means that pressure increases very low. Consider 1.0001 and then it increases to 1.0002. Increasing occurs to its reach to pressure of 2 bar. Okay, it's quasi-equilibrium. So we can use this integral of work in quasi-equilibrium process. But what happens when the quasi-equilibrium doesn't exist in the system? Consider a cylinder and piston. We have a high pressure in the piston. We exit the pin, black pin. You can see it in the picture. See it in the picture. You can exit the pin from the piston. What happened? During to high pressure of the system, piston instantaneously move to upper location of the initial state. So what happened to pressure? Pressure increases instantaneously and decreases It decreases. It decreases instantaneously. Okay, is a quasi-equilibrium process? No, it's not a quasi-equilibrium process because pressure is not variated very low during this process. The pressure has a instantaneously increasing or decreasing during this pressure. So it's true that we use the integral of P cross delta V. No, it's wrong. It's wrong. It's not a quasi-equilibrium process. Pressure inside the cylinder equal to P index 0 plus M mass of the piston cross G divided by R, area of the system. So this is the actual pressure of the system. So we use this term cross displacement of piston. It's not a quasi-equilibrium. The other example is the rupture of the things inside the cavity. The cavity have two parts. First part is gas and the other part is vacuum. What happened when the rupture occurred in the vacuum part? So pressure decreases instantaneously. So it's not also a quasi-equilibrium process. So we want to continue the lesson with the first law of thermodynamics. We talked that quasi-equilibrium process and first law of thermodynamics, that is first law of thermodynamics was cyclic integral of heat equal to cyclic integral of work. So we investigate the process. Process means from state 1 to state 2. What happened in state 1? What happened during this process? Consider a cycle this cycle has two processes, process A and process B. We move from state 1 to state 2 in process A, and we back to state 2 to state 1 from process B. The other process is the process is A from state 1 to state 2, and process C, that from state C to state 2 to state 1. Two of them is two cycle. Okay, cyclic integral of heat equal to cyclic integral of work. So differential of heat minus differential of work is equal to this process. Equal to this process. So the quantity of So, do you have my voice? Any problem in voice? Do you have my voice? Yes, okay, thank you. So the quantity of differential of Q minus differential of work in two processes A and C are equal because B is identical in two cycles. So we define this quantity that differential of Q minus differential of work is equal to all the process. It's a quantity that's only depend on initial and final state. So we define this quantity as energy. Energy differential of energy equal to differential of Q minus differential of work. If we integral of this term, E index 2 minus E index 1 equal to Q or heat from state 1 to state 2 minus work from state 1 to state 2. What is the energy? We define that energy equal to internal energy, kinetic energy, and potential energy. So we continue the lesson in the next session tomorrow. Any question? Any question? Okay. We continue the lesson tomorrow morning.
Okay, Doctor. No problem.
10 a.m. We start class. We will start the class 10 a.m. tomorrow. $11 o'clock is late. Okay, but we can change the class as you want in the other session. There are 2 lecture or 3 lecture in the week. We will have it. 2 or 3 lecture.
Doctor. Sorry, Doctor. You have me, Doctor?
Maybe Friday, Saturday, and Sunday. Not every morning. Okay, I accept that 2 sessions in the weeks is enough, but you consider to this subject and problem that we should end the class in 1 month. Okay, we only have 1 month or 1 month and a half to end the class. So it's a problem that we should more than 2 class in the week. Okay. Okay, and on the other important subject, please check the Ballet application one time in the day, please. I also add the file of the class in the LMS. You can enter the LMS and upload the file of the class for all the students that can participate in the class. Okay, you can see it offline.
Victor, we have a heavy lecture. So, of possible, well, we would approach having only 2 lectures per week on Thursday and Saturday.
Hello, Doctor. Do you hear me?
Yes, I can hear your voice.
Okay. Doctor, please, about the time and day of lecture. If possible, just Friday and Saturday. Because another days, all of them we in the work from 8 morning till 3, maybe 4 p.m. So if possible, just Friday and Saturday. This is help from your side, if possible. So that's possible, Doctor?
Yes, you are. I have a question. You
Yes?
are free in Friday and Saturday?
Yeah, just 2 days.
Okay, okay. What about Thursday?
Another day, all the days we have the work. You know,
Okay,
somebody's work
okay,
in the office and somebody's work in the company. So possible
okay.
just these 2 days. You can
Okay,
take
I
the time
accept that.
to.
We have
Thank
two
you so much.
sessions in the week, Friday and Saturday.
And what the time?
Tomorrow we don't have any class.
Thank you so much. And what the time about the lectures on Friday and Saturday at 10 o'clock every time?
Yes,
Every
it's 10
10
o'clock is
o'clock
good.
by Iraq time or Iran time?
Iran time.
Ah, that's good. 2 hours or how much time the lectures?
Uh, about 1 hour and a half.
Ah, 1.5 hours. 1 hours and half.
Yes,
Okay.
1.5.
Doctor, please, sorry if I take time from your side. About the mathematics, right now he didn't mention the degree in the Clistan. Just mathematics. If possible, just
Yes.
speak with him.
I will announce it in the during this week or end of this week.
Ah, this week or maybe
End
that's mean
of
maybe
this
next
week.
week, yes?
End of this week.
Ah, okay. Thank you so much.
Thank you
Thank you, Doctor.
also from you. Any other question?
Can give it to me just 1 minute? I ask my friend just too much 1 minute, just half minute. Let me discuss with our friend. Maybe somebody has question.
Okay, thank you. If you don't have any question, we can't close the
Thank you, Doctor.
class.
Thank
Thank
you,
you.
Doctor.
دکتر ببخشید
The next slide.
اوکی.
سلام دکتر، خسته نباشی.
سلام.
خوبی انشالله.
خیلی ممنون.
دکتر ببخشید من تو این سایت نیستم.
کدوم سایت؟
الان که دارید این ترمودینامیک.
خب پس چطور الان وارد شدی؟
وارد شدم، برام فرستادن، یه رابطی برام فرستادم، با چند تا برنامه داخل شدم، اما تو اینایی که دانشگاه برامون میفرسته نیستم.
شما باید اینو از دانشگاه بپرسین. من در جریانش نیستم، ولی هر جلسه کلاس رو بخواید شرکت کنی به همین شکل میتونید. یا میخواید شماره دانشجوییتون رو برای من بفرستید تو بله، من شما رو به کلاس اضافه کنم.
باشه دکتر، خیلی ممنون.
ولی یه موضوعی رو لطفاً توجه کنید، شما باید این درس رو
باشه.
داشته باشید تو گلستان.
آره باید
درس
این
براتون
درس رو
ثبت
داشته
شده؟
باشم.
تو
نه
گلستان
ثبت
این درس رو
نشده، فقط
داری؟
نه فقط 2 تا درس دارم. تو این ترمی الان که شده 3 تا، باید 3 تا درس داریم، من 2 تا دارم فقط.
پس ببین یه مسئله مهم، شما باید بدون مسئله رو دانشگاه حل کنید. چون من اگه شما رو
به
اضافه
دکتر
کنم، نه یه لحظه شما گوش کن، من اگه شما رو اضافه
باشه.
کنم به کلاس، خب شما آخر ترم نمیتونی امتحان بدی چون درس برای ثبت نشده.
مثلا
باز شما یه
با
کاری بکن.
دکتر رحیم
خب ببین الان من
تماس
بهت میگم،
میگیرم.
شما شماره دانشجویی تو برای من بفرست، من با آقای رحیمیان تو دانشکده میگم نگاه کنه ببینه مشکل چیه.
باشه خیلی ممنون دکتر، خسته نباشی، زحمت
خواهش
کشید.
میکنم، موفق باشین. خدا نگهدار.
خیلی ممنون.
گودبای.
خدا نگهدارش.